Find the number of different arrangement of 9 letters in the word delivered in which 3 E's are together and 2 D's are not next to each other. 9-letter word you have to construct, and the restriction is all 3 E's together. So 1, 2, 3. There would be E, there would be E, there would be E. Make a box around it because they should be treated as a first unit, single unit. Okay, 9-letter words this is. So 1, 2, 3, 4, 5, 6, 7, and no 2 D's together. So it means that 1, 2, 3, 4, and 5. There are basically 5 possible combination without the restriction of you can say D. So this will be treated as single unit. This is second, this is third, this is 4, and this is 5. So 5 possible combinations are there through which I can make a combination. Now no 2 D's together. It means that I have to make a separation between these. For example, here is lying, D is lying here, D is lying here, maybe here, maybe here, maybe here, and maybe here. These hats basically showing the combination for D's. So 1, 2, 3, 4, 5, 6. 6 possible arrangements are there through which I can arrange 2 D's. So 6p, 2. 1, 2, 3, 4, 5, 6. And how many times D repeated? 2 times. So you can write 5 factorial times by 6p, 2. Whole dividing by 2 factorial. Why I did 2 factorial? Because D is repeated 2 times, that's why. So once you solve it, you will get 1000 and 1800. That will be the answer. Alright, you can also solve this question in another way. Second method. Second method suggests that if you are making 9 spaces first, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spaces are there because we have to construct 9-letter word. So I'm creating a group around E. E's together. This is treated as a single unit. I'm not going to place any restriction for D. So 1 unit, 2, 3, 4, 5, 6, 7. It means that 7 combinations are possible. Whole dividing by the repetition. E's are 3 times. E's are 3 times in that word. D are 2 times. And all other words are single time. L is 1 times. R is 1 time. I is 1 time, and V is also 1 time. I make a group around around E, that is 3, and that is treated as a single unit. Okay, and D could be anywhere, maybe there and there. So I'm not placing any restriction for D. So that will be treated as the combination without any restriction. So 7 factorial dividing by 2 factorials, because the remaining spaces can be filled by the letters 2 D's, 1 L, 1 R, and 1 V. I can arrange these letters. So you can see D is repeating 2 times, so you can write 7 factorial by 2 factorial. Rest of the quantities are single unit, so that will be treated as it is. So this is the combination without any restriction. So you can write as total number of arrangements. Now I have to make a restriction for D, like no D's together. So I will treat it as I will find the number of combination in which 2 D's comes together. So if I'm going to write with a purple marker or a green marker, you can say. So combinations when all D's together. So E's are over here, and I'm creating a group for D together, there to there. Rest of the units are unfilled. 1 2 3 4. 1 2 3 4 5 6 7 8 9. Yes. So when all these comes together, that will become 1 2 3 4 5 6. 6 units are there. So it means that 6 factorial. 6 factorial are basically showing the number of ways through which I can arrange all these together. Now I will take away total arrangements minus when two D's are basically spent together, or you can say adjusted together. So you can write the formula as required number of ways, that will be total arrangements, total ways minus when D's together. So that becomes 7 factorial dividing by 2 factorial minus 6 factorial. That is the arrangement when without any restriction, without any has, or you can say without any restriction, total number of combination. And that 6 factorial is basically the arrangements whenever these two D's together, and I have to find the combinations or arrangements when no D's together. So it means that total ways minus when two D's together. In this way you can write that expression, and once you solve it on your calculator you will get the same result just like 1800. Okay. Second is find the probability that a random chosen arrangement of 9 letters in the word delivered has exactly 4 letters between the two D's. So find the probability that random chosen arrangement of 9 letters in the word has exactly 4 letters between two D's. Okay. So you can write 9 letter words, exactly 4 letters between two D's. It means that you have to specify the position of D. D could be there and exactly 4 letters between two D's. So 1, 2, 3, 4. D could be there. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the one possible combination that I can create. 1, 2, 3, 4. Yes. 4 words can be there between two D's. Next I can move D onto the other side, means 1 unit to the right. So second combination that I can create, D is there, 1, 2, 3, 4. That D is shifted over here, so that becomes here. Instead of 3 empty spaces at the right to the right, there will be 2 empty spaces. So this is the second combination. Third, you can write move that D 2 units more, means 1 unit more in the second combination and 2 units more in the first combination. So that becomes D over here, 1, 2, 3, 4. Move that one over here, so here and here. This is the third possible combination. Fourth, you can take 1, 2, 3, move that over here. That becomes here D. 1, 2, 3, 4, and that over here, here. So it means that that is the fourth possible combination. So total there are 4 combinations possible through which you can arrange the positions for D. Now go back to the question, is there any more restriction? 9 letters in the word deliver had exactly 4 letters between the two D's. No, there is nothing more. So you can see there are 4 letters between these two D's and 3 letters to the right, and the word is delivered. So let me write DE LI VERD. So these positions are fixed and E contains 2 times, and I can see there are basically 1, 2, 3, 4. Four options are there through which I can arrange D is cutted, D is cutted, because I fixed the position of D. So in these 4 empty spaces, I can arrange any any letters between E, L, I and V. Any letters can be arranged. So that could be treated as 1 empty space unit, 2, 3, 4, 5, 6, 7. It means that 7 possible options are there through which I can arrange the remaining letters, that are E, V, again E, then L and then I. 1, 2, 3, 4, 5. So it means that there are basically 7 empty spaces for these words to be arranged over here. Same for that. 1, 2, 3, 4, 5, 6, 7. 7 options are there for that word. Similarly for that, 1, 2, 3, 4, 5, 6, 7, and same for that, 1, 2, 3, 4, 5, 6, 7. It means that 7 factorial choice is same for everywhere. So I can write it as 7 factorial, and there are 4 combinations possible, so it means that I can write 7 combinations for everywhere. There, I'm going to highlight it. So how many total? 1, 2, 3, 4. So 7 factorial times by 4. Okay, now look, is there any number repeated for these 7 arrangements? Yes, this is E is repeated. E is repeated thrice. 1, 2, 3. Yes, E is repeated thrice. So it means that you can write 7 factorial over 3 factorial. These 3 factorial is for E's, times by 4, because 4 options are there. So number of ways through which you can arrange it as 4, 0, 3, 2, 0. This is the number of ways through which you can make a combination. But if you go back to the question, you can see probability that exactly random chosen arrangement of 9 letters in the word has exactly 4 letters between that. You have to find probability, not only the arrangement. So probability formula was that number of favorable outcomes dividing by the total outcomes. These are the favorable outcomes that satisfy our conditions. Total outcomes could be figured out by using the formula. 9 letters are there, out of which we have to choose total combinations. So total words are there. Okay, so you can write it as 9 factorial, because total outcomes are basically the total outcomes are the number of letters that involved in the word, so that would be treated as 9 factorial. So you can write the probability of favorable outcomes to the total outcomes, probability of A to probability of B, that could be written as 40320 over 9 factorial. Once you solve it, your answer will be coming as 1 by 9. In this way you can find the solution for that. Okay, next is find the number of different selection if the 5 letter include at least one D and at least one E. So 1 D and 1 E. You have to create all possible samples through which you can arrange these letters. So 5 letter words. So 1, 2, 3, 4, 5. I have to fix these 5 positions. There are restrictions that D's and E's. How many times D happens total? 2 times. E comes 3 times in the word delivered. There is a restriction at least 1 D and at least 1 E, and I have to create 5 letter words. It means that remaining one would be any figure, any word that can be maybe I, maybe L, maybe V, anything could be. So at least 1 D. At least 1 D means there is 1, and at least 1 E. So 1 E. I have to create 5 letter words. So here is E, here is D. 3 possible options are left behind. So they could be anything that comes under the X. X could be anything. Could be any letter. Okay. Second combination that you can create it as 1D, 2E, 2 plus 1 is 3. So remaining 2 would goes toward X. Third one, 1E, 1D and 3 E's, because E's are 3. Total E's are 3, and you can choose maximum at least 1, and maximum could be the total one of E's. X could become 1, 3 and 1. 1 and 3, 4. 4 plus 1 is 5. Okay. Then maximum condition for the D is 2. So you can write it as 2 D's and 2 E's. 2 plus 2 is 4. So 1 goes toward X. 2 D's and 1 E and 2 could be X. If you create 2 D's, 2 E's, so 0 could be there. 2, 2 and you can take 3 E's because that combination is already goes over here, 2, 2 and 1. So 2 D's, 3 E's and 0X. So 5 letters comes over here. So it means that total combination that I can create 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 combinations are possible for it. So I will find the combination of it first. Just write it down as 2C1, because total D's are 2, out of which I am getting 1, times by total E's are 3, 3C1 times by total X, 5, and X could be treated as 4, because out of 9 letters 2 are D's, 3 are E's, so 5 would be take off from 9, so that becomes 4. So X could be 4, out of which I am taking 3. That will give me the answer. Once you solve on your calculator, you will get 2C1, 3C1, 4C3. That is coming as 4. Okay, next one is 2C1, 2C, 3C2, 4C2. That is coming as 6. 2C1, 3C3, 4C1. That is coming as 4. 2C2, 3C2, 4C2, 4C1 actually, this is 4C1. So that is coming as again 6. 2C2 for that one. 3C1 and 4C2. That is coming as 4. And the last one, 2C2, 3C3, 4C0. That is coming as 1. Now you have to add up all these terms together that I'm going to highlight with a green marker. This one, this one, this one, this one, this one, this one, this and this. Add up all these possible combinations together. That will give you the total number of ways through which you can arrange these letters together. 4 plus 6 is 10. 10 plus 4 is 14. 14 plus 6 is 20. 20 plus 4 is 24. 24 plus 1 is 5. 25. So total combination would be 25. In this way you can arrange. You can also confirm the answer key. It's question number 7. So first one is 7 factorial by 2 factorial minus 6 factorial, that is 1800. Okay. 7b is coming as 1 by 9. Yeah, it's fine. And 7c is coming as 25. Yeah, that's fine too.